On October 29th, 2025, a comet named 3I Atlas did something impossible, and the entire world saw it happen in real time. This wasn't just another space story. It was a global moment of discovery that broke every rule we thought we knew about comets. If 3 Atlas isn't just a rock, if it's truly something intelligent, then the next few hours could reveal the biggest secret in human history. Subscribe now. Every new signal, every strange move, you'll see it here first. It was a date marked on calendars around the world, October 29th, 2025. This was the day that 3I Atlas, a visitor from beyond our own family of planets, would make its closest pass by the Sun. It was a special moment. Everyone was watching. Astronomers, both in giant observatories and in their own backyards, had their telescopes pointed at this one spot in the sky. It was a global event, a shared moment of looking up and wondering. This comet was not from around here. It had travelled for thousands, maybe millions of years, from a star system far, far away, and now it was putting on a show for us. The whole world held its breath, waiting to see what this traveller from the stars would do as it felt the sun's powerful heat. For months people had prepared for this. They had tracked its path. They had guessed how bright it might get. But no one, not a single person, was prepared for what was about to happen. This was supposed to be a quiet, predictable event, a simple flyby, a chance to study a piece of another solar system up close. The world was tuned in, ready for a calm, scientific observation. It was the day the comet broke the internet. What happened next was not calm. It was not predictable. In the middle of this global watch, something unbelievable occurred. Suddenly, the comet flared. This wasn't a small change. It was a huge, violent explosion of light. Imagine a tiny, faint speck in the sky. Now imagine that speck suddenly turning into a brilliant star. In just a few minutes, 3I Atlas became 4 times brighter than it was supposed to be. It was like a miniature sun had just been switched on in the darkness of space. It was so bright that people in dark areas could almost see it without a telescope. For the astronomers watching, it was a moment of pure shock. Their screens, which had shown a tiny fuzzy dot, were now flooded with light. The brightness was off the charts. It was an event so powerful, so unexpected, that it sent a wave of confusion and excitement across the entire planet. What could cause a comet to do this? Comets were supposed to be simple balls of ice and dust. They weren't supposed to act like exploding stars. This single, brilliant flash of light was the first sign that 3I Atlas was no ordinary comet. It was the first clue that we were witnessing something that would rewrite the books on space. The story of this discovery didn't start in a big, fancy lab. It started in a backyard in Australia. An amateur astronomer, a person who studies the stars for the love of it, was recording the comet. He had his camera hooked up to his telescope, taking pictures one after another. He wanted to create a time-lapse video, a movie showing the comet's slow journey across the sky. When the flare happened, his camera caught it all. He watched his own footage back, his eyes wide with disbelief. The comet just exploded with light. It was so strange, he thought maybe his camera was broken. He had to know if anyone else saw it. So he did what people do in our modern world. He went online. He quickly put his short video together and posted it on Twitter. He added a simple message. It said, "Did anyone else get this?" He added the hashtag #Juster3Atlas, so other comet watchers could find it. He had no idea that his simple question was about to light a fire that would spread across the entire globe. He thought he was just one person who saw something weird. He was about to find out that he was the first person to alert the world that something impossible was happening millions of miles away. The response was instant. It was a digital tidal wave. Within an hour, his post was flooded with replies, hundreds of them. And they weren't just from Australia. They came from Japan. They came from South Korea. They came from India. They came from every country where the night sky was clear enough to see the comet. People were all saying the same thing. Yes, we saw it too. My telescope caught the same flash. What is happening? Each reply came with its own proof. People posted their own pictures. They shared their own videos. They uploaded charts showing the sudden spike in the comet's brightness. It was a global chorus of confirmation. The event was real. It wasn't a camera glitch. It wasn't a mistake. It was a genuine, mysterious event that had been witnessed by hundreds of people, all at the exact same moment. The internet became a giant worldwide laboratory. Everyone was sharing their data, comparing their notes, and trying to figure out what was going on. The power of so many people watching at once was incredible. No single observatory could have verified the event this quickly. But the crowd, the global community of skywatchers, did it in less than an hour. The explosion of activity wasn't just on Twitter, it spread like wildfire across every corner of the internet. Online groups, places where people with shared interests talk, went into overdrive. Discord servers, which are like chat rooms for communities, were buzzing with energy. Channels that were usually quiet were now filled with hundreds of people all typing at once. They shared settings for their telescopes. They gave each other advice on how to best capture the comet's new brilliant light. On Reddit, a huge online forum, the astronomy section became the centre of the world's attention. Threads about 3i Atlas had thousands of comments. People were analysing the data in real time, creating graphs and charts on the fly. The story wasn't just for astronomers anymore. It crossed over to everyone. On Instagram and TikTok, short videos of the glowing comet went viral. People who had never looked at the sky before were now outside, trying to get a glimpse of this strange new star. The internet connected everyone to this single cosmic event. It felt like humanity itself had a shared experience, a moment where we all looked up at the same thing and asked the same question. What is that? For countless people, this was more than just a news story about a comet. It was a moment of connection. In a world that often feels divided, where people disagree on so many things, this was a moment of pure, undeniable agreement. Everyone saw the same flash of light. Everyone saw the same sudden brightening. The data from a telescope in Chile matched the data from a telescope in Spain. A picture from a phone in California showed the same new star as a picture from a professional camera in Germany. It was a moment of shared discovery. The feeling was electric. It was a sense that we all saw it at once. There was no argument. There was no debate about whether it happened. The proof was everywhere, uploaded by everyone. It was a rare moment of global unity, brought to us by a mysterious object from another star. People felt like they were part of a team, Team Earth, and together they were all trying to solve a brand new mystery. This shared experience was powerful. It turned a distant astronomical event into something personal, something that everyone felt they were a part of. The speed of this discovery was something new. In the past, a strange event in space would be seen by a professional observatory. The scientists there would study their data for weeks or months. They would double-check everything. Then, they would write a paper and announce their findings to the world. But this time, the world didn't wait. The news didn't come from an official source. It came from the people. News websites and television channels found themselves in a strange position. They were behind the story. They were trying to catch up to what everyone on the internet already knew. The crowd owned the story. The narrative was being written in real time on forums and social media. People were verifying the event with each other before any expert had a chance to make a statement. By the time the big news organizations started reporting on it, the online community had already confirmed the flare, measured its brightness, and was already moving on to the next question. What caused it? This event showed that the power of discovery was changing. It was no longer just in the hands of a few experts. It was now in the hands of anyone with a telescope and an internet connection. The world was watching, together, and the story of 3i Atlas had only just begun. The internet had been broken, but a new global scientific community had just been born. Everyone felt the excitement. Everyone was part of the team, and nobody knew what was coming next. This was a mystery for the entire planet to solve. The comet had our attention, and it was not going to let it go. The single flash was just the beginning. The real story was about to unfold, frame by frame, as captured by the watchful eyes of the world. But here's where the story gets even stranger. What if everything we thought we knew about comets was completely wrong? The world was able to see the comet's strange behaviour for one simple reason. We were ready for anything. The global watch that captured the flare was no accident. It was the result of months of careful planning and cooperation. And it all started with the fact that 3i Atlas was not just any comet. It was an interstellar visitor. This made it incredibly special. In all of human history, we had only confirmed 2 other objects that had come from another star system. 3i Atlas was the third. Imagine a message in a bottle, not from across the ocean, but from across the vast empty space between stars. That's what this comet was. It was a piece of another solar system, visiting ours for a short time. Because of this, its closest approach to the Sun was one of the most anticipated events in modern astronomy. Scientists knew this was a rare chance to study the building blocks of another part of the galaxy. They wanted to know what it was made of, how it was formed, and what secrets it carried from its distant home. This wasn't just another rock in space, it was an alien messenger. And so, the entire world prepared to watch it closely. Every telescope that could be pointed at it was. This level of focus, this global attention, set the stage for the incredible discoveries that were to come. We were watching because we knew it was special. We just didn't know how special it would turn out to be. The most amazing part of this global watch was not the big professional observatories. It was the network of everyday people. Backyard astronomers from all over the world had decided to work together. For months before the comet's arrival, they had been organising themselves. They used online tools like Discord, a popular chat app, to create a massive coordinated team. It was like building a global neighbourhood watch for the sky. They mapped out a plan. They knew that as the Earth turns, some parts of the world are in daylight while others are in darkness. To watch the comet continuously, they needed to pass the job from one continent to another. So they created a schedule. They set up coverage shifts. As the sun set in one part of the world, a team of astronomers there would begin their observations. They would track the comet for hours. Then, just as the sun was about to rise for them, they would hand off the duty to another team on another continent where night was just beginning. It was a non-stop 24-hour watch, powered entirely by volunteers. This global network of amateur skywatchers was a powerful new force in astronomy. They were organised, they were dedicated, and they were about to play a huge role in this story. This wasn't just a loose collection of people. It was a highly organised effort. Amateur astronomy clubs from different countries formally agreed to sync their observations. A club in Japan, for example, would coordinate directly with a club in Chile. A group in South Africa would time their work to overlap with a group in Australia. This created a seamless chain of data. They wanted to make sure there were no gaps. They wanted the comet to be watched every single second of its journey near the sun. This level of coordination between amateur groups on different continents was something new. They used shared online calendars to schedule their shifts. They had live voice chats open so they could talk to each other in real time, even if they were thousands of miles apart. Okay, Japan team, we are seeing clear skies. We have the comet in view. Roger that, Japan. This is Chile. We're about 3 hours away from sunset. We will be ready to take over. It was like a global mission control, but it was run by regular people from their own homes. This dedication ensured that when 3i Atlas did something strange, not just one person would see it, but a whole chain of people, ready to confirm it instantly. While the amateurs were organising on the ground, the professionals were getting ready in space. The world's biggest space agencies, like NASA and the European Space Agency, were not going to miss this opportunity. They had powerful tools in the perfect position to watch the comet. Two of their most important missions were the Parker Solar Probe and the Solar Orbiter. These are spacecraft designed to study the sun up close. They fly in orbits that take them nearer to our star than any spacecraft have ever been before, and as it happened, their schedules lined up perfectly to get a front-row seat for the 3i Atlas show. Mission controllers on Earth adjusted the spacecraft's plans. They repointed their cameras and sensors. They made sure that these multi-billion-dollar eyes in the sky were also locked onto the interstellar visitor. This meant we would have two sets of data, the view from Earth and the view from deep space, close to the sun itself. This combination of viewpoints would be incredibly valuable. The space probes could see things that telescopes on Earth could not, because they didn't have to look through our planet's atmosphere. The network of observers wasn't limited to Earth and the sun's inner orbit. It extended even farther out into the solar system. We had spacecraft orbiting Mars. These orbiters, which are normally busy studying the red planet, had already seen 3i Atlas. They had spotted it weeks earlier as the comet was making its way in from deep space. Now, they were given a new task. The mission scientists on Earth sent them new commands. They were told to turn their cameras away from Mars and look out into space. They were instructed to capture any activity they could see from the comet. This added yet another layer to the global observation effort. We now had eyes on Earth, eyes near the sun, and eyes at Mars. It was like setting up cameras all around a stage to make sure you capture the performance from every possible angle. This multi-planet observation campaign was one of the most complex ever attempted, and it meant that the data collected on 3i Atlas would be some of the most complete and detailed ever gathered for a comet. We were truly ready for anything it might do. Back on Earth, the number of telescopes pointed at the comet was staggering. It wasn't just a few dozen, it was hundreds. These telescopes represented a huge range of technology. Some were homemade. They were built by hand in garages and workshops by people who simply loved the stars. These simple, clever machines were aimed at the sky, alongside some of the most high-tech amateur telescopes money could buy. These were advanced, computer-controlled instruments that could track objects with incredible precision. And of course, the giant professional telescopes at mountaintop observatories were also part of the team. All of these instruments, from the simplest to the most complex, were locked onto the comet's predicted path. This army of lenses and mirrors, spread across every continent, formed a single, planet-sized observatory. Every one of them was a pair of eyes for humanity, staring intently at this one tiny point of light, waiting for the story to unfold. To manage the flood of information that was about to come, the community had built a streamlined system. This wasn't just about taking pictures. It was about sharing them instantly and in a way that was useful for science. Online spreadsheets were created where people could log their observations. They would enter the time, their location, the equipment they used, and a link to their data. Special computer scripts were written and shared among the group. These scripts helped to automate the process of taking images. A person could program their telescope to take a picture every 30 seconds, automatically save it, and even upload it to a shared online folder. This meant that data from hundreds of telescopes was flowing into a central public place almost in real time. Anyone in the world with an internet connection could access this data. They could see the raw images from a telescope on the other side of the planet just moments after they were taken. This system was a model of open, collaborative science. It was built on trust and a shared passion for discovery. It was this incredible level of organization that made the discovery of the flare so powerful. When that first backyard astronomer in Australia posted his video, he wasn't just shouting into the void, he was shouting into a room full of people who were all looking at the exact same thing. The system they had built was ready. The flare happened, and immediately countless eyes and instruments captured it. The data wasn't just in one place. It was in hundreds of places on hard drives and servers all over the world. There were pictures, there were brightness measurements, there were videos. The evidence was overwhelming and it was available instantly. This high level of readiness meant that the story didn't stop with the flare. The global watch was just getting started. The organized network of observers, both amateur and professional, had captured the opening act. Now, as the comet continued its journey, they would be there to capture every detail of what came next. The world was watching, prepared, and united. And the comet had a lot more surprises in store. The foundation had been laid for a new kind of discovery, one driven by the power of a connected and prepared global community. The story now moves across the globe, following the darkness. As the Earth turned, the spectacle of the flaring comet became visible to new parts of the world. In the United Kingdom, clouds had blocked the view for most of the early night. But then, a lucky break came. The sky began to clear, and as it did, a group of dedicated amateurs sprang into action. They were part of a Discord group, a chat community focused on UK astronomy. For hours, they had been anxiously watching the reports pour in from Asia and Australia. They felt like they were on the sidelines, waiting for their chance to get in the game. When the clouds finally parted, it was their turn. And it was here, in the quiet of the British night, that observers saw the first crack in the comet's body. What UK amateurs saw in their own backyards would provide the first hard evidence that 3i Atlas was not just flaring, it was breaking apart. Leading this UK network was a man named Colin. He was a retired engineer, a person who spent his life working with precision and details. He brought that same careful approach to his hobby of astronomy. He knew that for their observations to be useful, they needed to be more than just pretty pictures. They needed to be scientific data. So, he had organised his group with an engineer's mind. He created a strict plan for them to follow. Everyone in the network had to take images in a specific way. The most important rule was that every single picture had to be precisely timed. They used GPS signals to sync the clocks in their computers. This meant that an image taken by one person in the south of England could be perfectly matched with an image taken by another person in Scotland. Colin's plan was for everyone to upload their images every 45 seconds. This would create a high-speed, detailed movie of the comet's behaviour. He was building a system to capture not just a single moment, but the flow of events, second by second. Colin was at his own telescope, in his own garden shed, which he had converted into a small observatory. He watched as the images from his camera appeared on his computer screen, one every 45 seconds just as planned. He was looking at the heart of the comet, a part called the nucleus. This is the solid centre, the small dark body hidden inside the fuzzy glow of the comet's coma. At 3:12 in the morning, universal time, the nucleus looked like a single, sharp point of light. But on the next image, at 3:12 and 45 seconds, it looked a little different. It seemed longer, elongated. He leaned closer to the screen. The next image confirmed it, and the one after that. Over the next 18 minutes, from 3:12 to 3:30, he watched in amazement as the single point of light stretched and then split. It broke into multiple distinct points of light. The comet was falling apart right before his eyes. He wasn't just seeing a flare anymore. He was seeing the comet's core shattering into pieces. The sight was both thrilling and deeply puzzling. This was the first evidence of the comet's physical breakup. As a careful engineer, Colin's first thought was that he had made a mistake. Maybe something was wrong with his telescope. Maybe his camera had a glitch. The sky is full of things that can trick you. A satellite could have passed by. A cosmic ray, a tiny particle from deep space, could have hit his camera's sensor and created a fake point of light. He had to be sure that what he was seeing was real, so he went back to his raw data. These are the pure, untouched files directly from the camera. He carefully checked everything. He looked at the shape of the new points of light. They were sharp and clear, just like the stars in the background. That meant they were not a smudge or a camera error. He checked multiple frames. The points of light were there in every single one, and they were moving. They were slowly drifting apart from each other. This was the key. A camera glitch would be random. A cosmic ray would appear in only one frame. But this was a consistent pattern of movement. The fragments were real. His data was solid. He knew he had captured something incredibly important. The true power of the UK network was about to be proven. Colin wasn't working alone. He immediately shared his findings in the Discord group. "Check your frames from 0315 onwards," he wrote. "I think I see a breakup." Within minutes, replies started coming in from other members of the UK network. "Confirmed. I see it too. My images show the same thing, 3 main fragments. I'm seeing 4 points of light now." They quickly started sharing their images. One person was using a different type of camera. Another had a different type of telescope. Someone else was over 100 miles away. But all of their images showed the exact same thing. They saw the same pattern of breakup. The fragments were in the same positions relative to each other. By having multiple people with different equipment in different locations all see the same thing, they could be absolutely certain that it was real. This was not an illusion. It was not a mistake. The comet was truly fragmenting. The network that Colin had built was working perfectly. The sun was not yet up in the UK, but the team was working at high speed. As soon as they confirmed the breakup, they started to process and share their data publicly. They didn't wait for permission. They didn't wait for a scientific journal. They wanted the world to see what they were seeing right now. They took their best sets of images and created animations, showing the comet splitting apart. They carefully marked or annotated the frames, circling the new fragments and labeling them. They uploaded everything to public forums and data-sharing websites. By the time the sun rose over the UK, they had already made over 200 of these annotated frames available for anyone to download and study. They included all of their notes. They included their raw data files. They were being completely open and transparent. They were not just saying, "We saw something." They were saying, "Here is all of our proof, look for yourselves." This act of instant open sharing was a game changer. It meant that the global community didn't have to wait for an official announcement. They could see the evidence with their own eyes, thanks to this small, dedicated team of amateur astronomers. Colin, using his engineering skills, did a quick early analysis of the images. He wanted to understand how the fragments were moving. He loaded the images into a special software program that could measure the positions of objects in the sky with great precision. He tracked the movement of each individual fragment from one frame to the next. What he found was remarkable. The fragments were not tumbling away randomly. They were moving in a very organized way. They were slowly expanding like a fan opening up. And they were all moving along a single, common line. The precision was stunning. It was as if something had carefully pushed them apart, all in the same direction, all at a steady speed. This was not what a normal comet breakup looked like. Usually, when a comet's nucleus shatters, the pieces are thrown out in all directions. It's a messy, chaotic explosion. But this was different. It was clean. It was orderly. It was almost geometric. Colin's initial measurements were the first hint of another deep mystery about 3I Atlas. Not just that it broke apart, but how it broke apart. The data provided by Colin and his UK network became the foundation for the next phase of the discovery. Because they had shared their raw files, anyone in the world could perform their own analysis. People didn't have to take their word for it. They could download the data and check it themselves. This amateur data, captured from backyards and garden sheds, was as good as, and in some ways better than, what was coming from the big professional observatories. It was better because it was available immediately. There was no delay. There was no review process. It was raw, open, and ready for the world to study. This became the backbone for a massive crowdsourced investigation. Thousands of curious minds from all over the world would now take this data and begin to unpack its secrets. The first crack had been seen. The evidence was on the table. Now the crowd takes over. The next chapter of this story would be written not by a small team, but by the combined intelligence of thousands of people working together online. The mystery of 3I Atlas was about to get much deeper. The moment the UK data was posted online, the internet exploded once more. This time, the focus was on a specific thread on Reddit in the Astronomy community. This online forum became the global headquarters for the investigation into 3I Atlas. The thread was flooded with activity. It quickly grew to have over 50,000 comments. This wasn't just casual chatter. It was an intense collaborative effort. Users from every continent were involved. There were professional astronomers, university students, computer programmers, artists, and people who were just curious. They were all working together, sharing their skills and their data. The thread was a living, breathing document of a discovery happening in real time. People shared their own images to confirm the UK findings. They posted links to the raw data files. They offered theories. They asked questions. It was a chaotic but brilliant example of the power of the crowd. The investigation was now fully public, and thousands of people had joined the team. The puzzle of 3I Atlas was about to be unpacked piece by piece by this global volunteer army of analysts. The first thing the community did was to combine all the available images. One person would download a set of pictures from an astronomer in Japan. Another would grab the data from the UK network. Someone else would find images from a telescope in Arizona. Then, using imaging software, they would overlay these pictures on top of each other. This process, called stacking, allows you to create a much deeper, more detailed image than any single picture alone. As more and more data was added, the image became clearer. The faint, fuzzy glow around the comet, the coma, became easier to see. The newly formed fragments stood out sharply against the blackness of space, and as these crowdsourced combined images were posted on the Reddit thread, something shocking began to appear. It was a pattern that no one had expected. It was something that seemed to break the laws of physics. The debris from the comet was not just a random cloud. It was expanding in a nearly perfect shell, a sphere of debris growing outwards like a bubble. The detail in these combined images was amazing. The community was able to identify at least 12 separate fragments. Each one was a tiny point of light, a piece of the original comet's nucleus, and each one had its own faint glow, its own tiny coma. But what was truly astonishing was their spacing. The fragments were not scattered randomly. They were positioned with an uncanny precision. It was as if someone had placed them there. They were maintaining their relative positions to each other as they all moved outwards from the center. If you drew lines between them, you would see a beautiful geometric pattern. This was completely unheard of for a comet breakup. It was so perfect, so orderly, that many people's first reaction was that it had to be a mistake. It had to be an error in how the images were being combined. But as more data from more independent observers was added to the stack, the pattern only became clearer. The perfect shell was real. The breakup had another dramatic effect. The coma, the cloud of gas and dust around the fragments, began to grow at an incredible speed. Before the event, the coma was a respectable size, but now it was expanding rapidly. Using the combined images, the community was able to measure its diameter. It had swollen to over 400,000 kilometers across. To put that in perspective, that is wider than the distance from the Earth to the Moon. The comet had transformed from a small icy body into a gigantic ghostly cloud in a matter of hours. This rapid expansion was another piece of the puzzle. It suggested that a huge amount of material had been released during the breakup event, but it didn't explain the orderly way in which the solid fragments were moving. The comet was behaving in two different ways at once. Its gas cloud was expanding as you might expect, but its solid pieces were moving in a way that defied all expectations. While some people were working on creating beautiful images, others were focused on the hard numbers. Small groups of amateur scientists formed, specializing in something called photometry. This is the science of measuring the brightness of objects in the sky. Using open-source software, tools that are free for anyone to use, they began to carefully measure the brightness of each of the 12 fragments. They also measured their positions in each frame of the available videos. Their work confirmed what the pictures were showing. The rate of expansion was uniform. The fragments were all moving outwards at almost the same speed. And the symmetry of the debris shell was real. They created graphs and charts that showed this with cold, hard data. Their work was rigorous. They shared their methods openly so anyone could check their calculations. This was citizen science at its best. It was disciplined, it was transparent, and it was producing results that were as reliable as any professional study. And their results all pointed to the same conclusion. The breakup of 3I Atlas was not a natural chaotic event. It was something else. The strangeness of this pattern could not be overstated. To understand why it was so weird, you have to think about how comets normally break up. A comet is not a solid rock. It's more like a loose snowball made of ice, dust, and pebbles. It's often called a dirty snowball. When it gets close to the sun, the heat causes the ice to turn directly into gas. Sometimes, this process can be uneven. Gas can burst out from a weak spot. This can cause the comet to spin, or even to crack apart. When it does crack, the breakup is messy. It's like a grenade exploding. The pieces are thrown out with different speeds and in different directions. They tumble and spin. The result is a chaotic, messy trail of debris. There is no order, there is no pattern. But 3I Atlas was the complete opposite. It seemed to have come apart with incredible discipline. It was as if it didn't shatter, but rather unfolded. The phrase that kept appearing in the online discussions was that the fragments looked like they were set out with a ruler. This simple, non-scientific description captured the mystery perfectly. It was a pattern that looked artificial. It looked like it had been designed. The speed at which all of this was discovered was breathtaking. Within just 12 hours of the UK data being posted, the global online community had achieved something incredible. They had taken raw data from dozens of different sources. They had combined it, processed it, and analysed it. They had mapped the entire debris field in 3 dimensions. They had calculated the speed and direction of each of the 12 fragments. They had measured the size and growth rate of the coma. The level of detail in their analysis was astonishing. It was the kind of work that would normally take a team of professional astronomers weeks or months to complete. But the crowd had done it in half a day. They had proven that a large, motivated group of amateurs could work together to produce world-class scientific results. They had taken ownership of the mystery, and in doing so they had revealed a central truth about 3I Atlas. Its breakup was not just unusual, it was a deep, profound puzzle that challenged our most basic understanding of how comets are supposed to behave. The perfect shell of debris was a beautiful and deeply unsettling new clue. As the world was still trying to understand the comet's strange breakup, another type of data began to appear online. This was a different kind of observation. It didn't show what the comet looked like, but what it was made of. This is done through a technique called spectroscopy. It's like putting the comet's light through a prism. Just as a prism splits sunlight into a rainbow of colours, a spectroscope splits the light from any object into its own unique pattern, called a spectrum. This pattern has bright or dark lines in it, which act like a fingerprint. Each chemical element, like oxygen or carbon or iron, has its own unique fingerprint of lines. By studying the spectrum of 3I Atlas, scientists could figure out exactly what it was made of. And as soon as the fragments appeared and the coma grew larger, this new light was captured and analysed. The results would add another, even stranger, layer to the mystery. The comet wasn't just ice. It was a metal comet. The data came from both professional observatories and from some very advanced amateur astronomers who had the right equipment. The moment they saw the results on their computer screens, they knew something was wrong. The spectrum was dominated by incredibly strong signals, or emission lines, from two metals, nickel and iron. These lines were so bright, so prominent, that they were the most obvious feature of the entire spectrum. It was like looking at a fingerprint and seeing two of the lines glowing with a brilliant neon light. This was a huge surprise. Comets are supposed to be made mostly of frozen water, carbon monoxide and other ices, mixed with dust. When these ices turn to gas, they produce their own spectral lines. You expect to see the fingerprints of water and carbon very clearly. Metals like nickel and iron are thought to be present in comets, but only in very tiny amounts, trapped within the dust. Their spectral lines are usually extremely faint, almost impossible to see. But in the spectrum of 3I Atlas, the metal lines were the main event. The first scientists who saw this data thought it had to be an error. Maybe their instrument wasn't calibrated correctly. Maybe there was some kind of reflection inside their telescope that was creating a fake signal. This was such an extraordinary claim that it needed extraordinary proof. So they checked everything. They recalibrated their instruments. They took new measurements. They had other astronomers at different observatories look at the comet with their own spectroscopes. Everyone got the same result. The powerful signatures of nickel and iron were real. They were not a mistake. They were an undeniable fact. The comet was spewing a huge amount of vaporized metal into space. This confirmation sent a shockwave through the astronomical community. Comets were not supposed to do this. This object was breaking yet another fundamental rule of what a comet should be. The mystery deepened when they looked at the details. They measured the strength of the nickel signal compared to the iron signal. This gives you the ratio of the two metals. In our own solar system, in the sun, in asteroids, in planets, this ratio is very consistent. There is always much more iron than nickel, but in 3I Atlas, the ratio of nickel to iron was 0.74. This number may not sound exciting, but to an astronomer it was mind-boggling. It meant there was almost as much nickel as there was iron. This was many, many times higher than the ratio found in any comet from our solar system. It was higher than the ratio found in almost any asteroid. This wasn't just a small difference. It was a fundamental chemical anomaly. Whatever this object was, it was not made of the same stuff as the objects in our own cosmic neighbourhood. Its chemical makeup was truly alien. The presence of so much metal led to a new idea about the comet's structure. Maybe 3I Atlas wasn't a dirty snowball at all. Maybe it had a solid metallic core. Using the brightness of the fragments and the amount of metal seen in the spectrum, scientists could make a rough estimate of the comet's density. The numbers suggested that the core was not a loose porous pile of icy rubble, as is expected for a comet. Instead, the density seemed to be much higher, closer to that of solid metal. This was a radical idea. It meant that 3I Atlas might be less like a comet, and more like a strange metallic asteroid that was somehow behaving like a comet. But that just created a new set of questions. If it had a solid metal core, how did it break apart so perfectly? And how did it release so much gas and dust to create its giant coma? The pieces of the puzzle were not fitting together. Each new piece of data just made the mystery harder to understand. One of the biggest puzzles was how all this metal got vaporized in the first place. Iron and nickel are strong metals. They have very high boiling points. To turn solid iron into a gas, you need to heat it to thousands of degrees Celsius. But 3I Atlas was still quite far from the sun. The surface temperature of the comet should have been far too low to vaporize iron. So how could its spectrum be filled with the light of gaseous metal? Experts were baffled. They wondered if the breakup event itself had generated a huge amount of heat. Perhaps the fragments were crashing into each other, creating sparks and high temperatures. Or maybe there was some unknown chemical reaction happening on the surface of the fragments that was releasing a lot of energy. No one had a good explanation. The physics just didn't seem to work. The presence of so much vaporized metal so far from the sun was another impossible fact that had to be explained. The final and perhaps most confusing piece of the spectroscopic puzzle was what was missing. While the spectrum was full of nickel and iron, it showed very little evidence of water. Water is the main ingredient of most comets. It's the ice in the dirty snowball. When comets get near the sun, this water ice turns to gas and creates the coma. The spectral fingerprint of water should be one of the strongest signals. But for 3I Atlas, it was incredibly weak. There was some water there, but not nearly enough to explain the size of the coma or the violence of the flare. This object was metallic and dry. It was challenging every textbook model of what a comet is. It wasn't a dirty snowball, it was more like a flying metallic rock that was somehow acting like a comet. The mystery of its composition was just as deep as the mystery of its orderly breakup. 3I Atlas was not just a strange comet. It was a new class of object, something that science had never seen before, and no one had any idea what it truly was. Let's return to the movement of the fragments. This was the mystery that had first captured the public's imagination, the perfect expanding shell. To truly appreciate how strange this was, it's important to understand what should have happened. The unnatural dance of the fragments, in their precise formation, was, perhaps, the most compelling piece of evidence that something very unusual was going on. When a normal comet breaks up, the process is driven by uneven heating and jets of gas bursting from the surface. Think of a spinning lawn sprinkler, but instead of water, it's shooting out gas and dust. These jets act like tiny, chaotic rocket engines. They push on the comet's nucleus, making it tumble and spin faster. If the spinning becomes too fast, the nucleus can't hold itself together anymore, and it shatters. The pieces are thrown off in all directions, spinning and tumbling on their own. The result is a messy, unpredictable trail of debris. There is no order, no formation. It is the definition of chaos. But 3I Atlas did not follow this script. Its fragments moved outwards almost in sync. They behaved as if they were all following the same set of instructions. They maintained their spacing with that uncanny regularity that people had described as being set out with a ruler. It was the opposite of chaos. It was order. It was symmetry. It was a pattern. This orderly expansion was observed not just for a few minutes or a few hours. It continued for days. As the fragments moved farther and farther apart, they kept their positions relative to each other. They were locked in a formation. It was like a squadron of airplanes flying in a perfect V-shape, but in this case, the formation was a three-dimensional sphere, expanding in every direction at once. This sustained, orderly movement was deeply puzzling. What force could possibly choreograph such a delicate dance of debris millions of miles away in the vacuum of space? This wasn't just a feeling or a casual observation. It was backed up by calculation. All over the world, people with a background in physics and engineering started running the numbers. University students working on their homework, professional engineers looking for a challenge, and retired scientists with time on their hands all joined the effort. They took the publicly available data on the fragments' positions and speeds. They then used the standard laws of physics, the same laws that describe how a baseball flies or how a planet orbits the sun, to predict how the fragments should have moved. Their models took into account the sun's gravity, the pressure from sunlight, and the expected chaotic push from outgassing jets. Every single one of these simulations predicted the same thing, a random, messy spray of fragments. The calculated, expected behavior looked nothing like what was actually being observed. The actual images told a completely different story. They showed a debris field expanding with remarkable symmetry and order. The contrast between the predictions of the models and the reality of the images was stark. It was a direct contradiction. This meant that either our understanding of physics was wrong, which was very unlikely, or there was some other force at play, something that was not included in the standard models. The online community kept returning to the simple analogy of the ruler. People joked that the fragments looked like they had been carefully placed. While it was a joke, it captured the essential mystery. The pattern looked designed. It looked artificial. It did not look natural. This feeling was unsettling. It pushed the boundaries of what seemed possible for a natural object. The beauty and mystery of this uniform expansion captivated everyone who saw it. People created stunning animations that showed the shell of fragments growing over time. These animations went viral, spreading far beyond the astronomy community. They were mesmerizing to watch. The slow, graceful, and perfectly synchronized movement of the 12 glowing points of light was both beautiful and eerie. It was a celestial ballet performed by the shattered pieces of a visitor from another star. Each new observation, each new animation, just deepened the mystery. The pattern was not an illusion. It was not a trick of the light. It was a real, physical phenomenon that nobody could explain. The fact that this strange movement was real was confirmed by the sheer number of people who saw it. The geometry of the expanding shell was consistent across hundreds of different observations. A telescope in a dark desert in Chile saw the same perfect spacing as a telescope on a rooftop in a city in Europe. Different cameras, different telescopes, different observers, different continents, they all produced the same result. This global consensus was crucial. It ruled out any possibility of a local error or a problem with one person's equipment. The evidence was undeniable. The fragments of 3I Atlas were moving in a way that defied our understanding of comets. They were engaged in an unnatural dance, a performance that hinted at forces and processes that were completely unknown to science. The question was no longer what happened to the comet. It was now, what is making the pieces move like that? The search for an answer would lead to even more speculation and controversy. The mystery of 3I Atlas took another strange turn when a new piece of information appeared online. It was not a picture, it was not a scientific paper, it was a simple spreadsheet, a file full of numbers. An anonymous user, with an account that had never been seen before, posted this file to a small specialized astronomy forum. The user's message was short. It claimed that the spreadsheet contained raw, unprocessed data from the Parker Solar Probe. This was the NASA spacecraft that was flying close to the Sun. The data, the user claimed, was about the trajectory of 3I Atlas. It was a record of the comet's exact position and speed as measured by the probe. This was the start of the leaked data mystery, and it would add a thick layer of conspiracy and intrigue to the already strange story of the comet. The numbers in the spreadsheet were complex, but for those who knew how to read them, they told a fascinating story. They showed the comet's path through space. A few expert amateur astronomers quickly downloaded the file and started to analyze it. They compared the positions in the spreadsheet to the official, publicly predicted path of the comet. The two paths were very similar, but not identical. There was a small, but consistent difference. The numbers in the leaked file seemed to show that the comet was not slowing down as much as it should have been as it moved away from the Sun. In fact, it hinted at a slight, unexplained acceleration. It was as if something was giving the comet a tiny, gentle push. This kind of non-gravitational force is sometimes seen in comets, caused by the rocket-like effect of gas jets. But the acceleration hinted at in this data did not seem to match what would be expected from normal outgassing. The appearance of this spreadsheet caused chaos on the forum. The moderators, the people who run the online community, were faced with a difficult choice. The data was completely unverified. There was no way to know if it was real or a clever fake. Allowing unverified information to spread could be irresponsible. So, they made a decision. They deleted the post and the file. They said it was a violation of their rules against posting unproven claims, but it was too late. In the short time the file was online, thousands of people had already downloaded it. They had saved it to their own computers. They had re-uploaded it to other websites. The data was out. And it could not be put back in the bottle. The attempt to remove it only made more people interested. It created a sense of mystery and conspiracy. What was in this data that was so secret? Now, the global community of citizen scientists had a new project. They began to intensely analyze the leaked file. Some people tried to prove it was real. They compared the numbers in the spreadsheet to their own measurements, taken with their backyard telescopes. Some of them found that the leaked data actually seemed to match their own observations better than the official predictions did. This suggested the data might be genuine. They argued that this was the real data, and the official predictions were wrong. They believed they were looking at evidence of a real, unexplained acceleration. This was a tantalizing clue. What could be pushing the comet? Was it related to the strange, orderly breakup? The questions were piling up. However, other analysts were more skeptical. They looked at the file with a critical eye. They pointed out that some of the information you would expect to see in a real data file from a NASA mission was missing. There were inconsistencies in how the data was formatted. Some of the numbers just didn't seem to make sense. These analysts argued that the file was probably a fake. They suggested it could have been created by someone who wanted to cause trouble or spread misinformation. Or perhaps it was a prank, designed to fool the excited community of comet watchers. The debate raged. Was the file a genuine leak, revealing a deep secret? Or was it a clever hoax, designed to prey on people's desire for a good story? There was no way to be sure. While the public was busy debating the leaked file, the official space agencies, NASA and the European Space Agency, remained silent. People flooded their social media accounts with questions. Reporters called their press offices. Everyone wanted to know, is this data real? The agency's response was frustratingly vague. They released short statements saying that the data from the Parker Solar Probe and other missions was still being collected and reviewed. They said that it would be released to the public once it had been properly checked and calibrated. They offered no comment on the leaked spreadsheet. They would not confirm or deny its authenticity. This official silence was like pouring gasoline on a fire. Why wouldn't they just say if it was fake? Their refusal to comment made many people believe that the data was real and that the agencies were trying to hide something. The lack of an official answer created a vacuum. And into that vacuum rushed all kinds of speculation and conspiracy theories. People began to imagine all sorts of reasons why the government might be hiding the truth about 3i Atlas. The theories grew wilder and wilder. The leaked data, whether it was real or not, had become a powerful symbol. It represented a deep division between the official closed world of professional science and the new, open world of citizen-led discovery. The public felt that they had a right to see the data. They had been part of the discovery from the beginning. They had captured the first images of the flare and the breakup. They felt that the mystery belonged to them, to everyone. The silence from the official channels felt like a betrayal. It only intensified the public's desire to find the truth for themselves, using their own tools and their own methods. The leaked data mystery added a new, human drama to the cosmic story of the comet. While the debate over the leaked data and the strange acceleration was consuming much of the internet's attention, some groups of citizen scientists decided to shift their focus. They felt that arguing about a single, unverified spreadsheet was a dead end. They wanted to do something more productive. They wanted to search for a different kind of evidence. This led to the rise of the People's Search. Amateur radio enthusiasts, people who use advanced radio equipment as a hobby, decided to take matters into their own hands. They would begin a systematic search for any artificial signals coming from the direction of 3i Atlas. And they would do it in a way that was completely open and transparent, so that everyone could see their results. The effort was organised in the same way the initial observations had been, through online communities. Amateur radio operators, often called hams, used Discord servers and old-fashioned email, mailing lists to coordinate their plans. These were people who were experts in radio technology. They knew how to build sensitive antennas. They knew how to filter out noise and interference from earthly sources. They were the perfect group to conduct such a search. They created a plan to divide up the sky and the radio spectrum. Different groups in different countries would be responsible for listening to specific frequencies. This would ensure that they covered as much of the radio dial as possible. It was a huge collaborative effort, powered by volunteers from all over the world. The work they did was incredibly disciplined. It was a true scientific search. They systematically logged every frequency they listened to. For each frequency, they would record the time, the duration of their listening session, and the amount of signal noise they detected. They saved all of this raw data, and most importantly, they shared it all publicly. They created a website where anyone could go and see their logs. You could see which frequencies had been checked, and by whom. You could even download the raw audio recordings and listen for yourself. This was a powerful statement. They were building a public, verifiable record of their search. They were not making any grand claims. They were simply and methodically doing the work and showing it to the world. After weeks of careful, coordinated listening, the result was clear. No artificial signals were detected. There were no strange beeps, no coded messages, no signs of intelligent communication coming from the comet. For some, this was a disappointment, but for the people involved in the search, the result itself was not the most important thing. The process was. They had proven something incredible. They had shown that a global network of amateurs, using their own equipment, could conduct a systematic scientific search for extraterrestrial signals. This was something that had previously been the domain of a few multi-million-dollar professional projects. The citizen scientists had shown that they could do it too, and they had done it with a level of transparency that was often missing from the professional world. This open approach was the most significant part of the people's search. The public could follow along every step of the way. They could see the planning discussions, they could see the data logs being filled out in real time, they could see the final results the moment they were confirmed. There were no secrets, there were no closed doors. This created a huge amount of trust. People knew that the results were reliable because they could check the entire process themselves. It was the exact opposite of the mystery surrounding the leaked acceleration data. The amateur radio operators were not just searching for signals from space. They were building a new model for how science could be done, openly, collaboratively, and with the public as an active partner. This shift in focus was an important moment in the story of 3i Atlas. The public's energy moved away from passively waiting for officials to release information. It was no longer about begging for answers from the authorities. Instead, people started to focus on what they could do themselves. They were actively building their own public, verifiable record of the event. They were creating their own datasets, their own analyses and their own conclusions. The tools and the expertise were now distributed among the crowd. The power to investigate, to search and to discover was no longer held by just a few institutions. This demonstrated a fundamental change in the relationship between the public and the scientific process. Science was no longer something that was done to people, or for people. It was something that was done with people. The citizens were not just spectators anymore. They were active participants. They were helping to set the research questions. They were collecting the data. They were analysing the results. The search for radio signals was a perfect example of this new era of open science. And it showed that even if the search for answers leads to a dead end, the journey itself can be revolutionary. The people had taken control of the search and in doing so had discovered their own power. By the time November arrived, the initial frenzy of discovery had started to calm down. The big, shocking revelations, the flare, the breakup, the metal content were now known. The internet had analysed the data to the best of its ability, but the energy and excitement did not disappear. It simply changed. It shifted from analysing the past to anticipating the future. The Comet, 3i Atlas, was on a path that would soon take it behind the sun from our point of view. It would be invisible to us for a few weeks, but everyone knew it would reappear on the other side in December, and so the world began to prepare for the next chapter. The anticipation for what happens next began to build. The global community was getting ready for round 2. A new sense of purpose filled the online astronomy forums. People launched official countdown timers, ticking down the seconds until 3i Atlas was expected to be visible again. These timers were shared widely, building a sense of collective excitement. A new wave of volunteers stepped up to help organise the next phase of observations. They had seen how successful the first global watch had been, and they wanted to be a part of the next one. Experienced amateur astronomers began to mentor newcomers, teaching them how to get the most out of their equipment. The community was growing, becoming more organised and more capable with each passing day. The first event had been a reaction. This next one would be a planned, deliberate scientific campaign. The community wasn't just waiting. They were actively preparing to be better observers. People who had captured blurry images of the first flare were now determined to get sharp, detailed pictures of the returning fragments. Threads on forums filled up with advice on how to upgrade equipment. People shared tips on which cameras were best, which filters to use, and how to improve the tracking of their telescopes. More advanced topics, like how to do their own spectroscopy, became popular. Experienced members created detailed tutorials and guides, complete with videos and step-by-step instructions. The entire global community was leveling up its skills. They were not going to miss a single detail when the comet returned. They were turning their shared passion into a shared expertise. The excitement around the comet's reappearance became a cultural event. It moved beyond the scientific forums and into the wider public conversation. Online betting pools even sprang up. People were placing bets, not on a sports game, but on scientific questions. What would the fragments look like when they returned? Would they have faded away, or would they be brighter? Would there be more of them? What new mysteries might the next round of data reveal about the comet's strange metallic composition? These were not just idle games. They were a sign of how deeply the public had become engaged with this scientific mystery. People felt invested in the outcome. They had been part of the story from the beginning, and they were eager to see how it would end. Through all of this activity, one feeling was unmistakable. There was a powerful sense of public control and ownership over the discovery process. The story of 3I Atlas did not belong to NASA. It did not belong to any university or government agency. It belonged to the people who had tracked it, photographed it, and analysed it. The crowd had claimed this discovery as its own. This was a profound shift. For centuries, the process of scientific discovery had been something that happened behind the closed doors of institutions. The public would only hear about the results long after the fact, through a press release or a news article. But 3I Atlas had changed that. The discovery was happening in the open, in real time, with the public in the driver's seat. This new sense of ownership was empowering. It changed people's view of what was possible. Discovery was no longer seen as a special privilege reserved for a small group of official experts. It was now seen as something that the crowd could achieve. This was a direct result of the official silence and the controversy over the leaked data. When the official institutions failed to provide answers, the public learned that they could find the answers themselves. They had the tools, they had the skills, and they had the power of their numbers. They didn't need to wait for permission to explore the universe. And so, as December approached, the global community was ready. They were more organised, better equipped, and more motivated than ever before. They were ready to catch whatever happened next. They had built a global, independent, and powerful network for scientific discovery, and they were going to use it, with or without official permission. This was the new era of public science, an era where the greatest discoveries might not come from a single genius or a giant institution, but from the collective curiosity of thousands of connected minds, all looking up at the sky together. The world was waiting for 3I Atlas to return. And this time, they were not just hoping to see something amazing, they were expecting it. To truly understand the importance of this moment, we need to step back and look at all the pieces of the puzzle at once. We need to summarize why this object was not just another comet. This was the impossible comet. Understanding why 3I Atlas breaks all the rules is the key to grasping the scale of the mystery it presented to the world. Each strange characteristic on its own would have been enough to make it a fascinating object of study. But taken all together, they painted a picture of something that simply should not exist according to our current understanding of the universe. It was a collection of contradictions, an object that defied every category we tried to put it in. First, let's recap the most basic and most important fact. 3I Atlas was an interstellar comet. It came from outside our solar system. This alone made it incredibly rare and valuable. As only the third such visitor ever confirmed, any unusual behaviour would be significant. Our solar system is like our house. We know the things in it pretty well. An interstellar object is like a visitor from another country, who we have never met before. They might have different customs, different ways of doing things. Studying 3I Atlas was a chance to learn about how things are in another house, in our galactic neighbourhood. The fact that this mysterious visitor then proceeded to behave so strangely made its story even more compelling. It wasn't just a tourist. It was a tourist that was breaking all the local laws. The first rule it broke was the flare. The sudden, massive increase in brightness was immense. It wasn't a slow brightening over days. It happened in minutes, and it was globally simultaneous. The fact that observers all over the world in different time zones recorded the flare happening at the exact same instant in universal time meant it was a single, powerful event. It wasn't a series of small pops. It was one big bang. This suggested that whatever caused the flare happened to the entire comet all at once. This is hard to explain with standard models of comets, which usually involve localized jets or surface collapses. The sheer scale and speed of the flare was the first clue that this was no ordinary object. The next, and perhaps most visually stunning, anomaly was the fragmentation. The comet's nucleus broke apart into at least 12 distinct pieces, but it was the way it broke apart that was so impossible. The pieces formed a nearly perfect expanding shell. This orderly geometric pattern defied everything we know about the chaotic nature of comet breakups. Comets are supposed to shatter. This one seemed to deploy. It was a controlled disassembly, not a messy explosion. This single observation, confirmed by hundreds of amateurs, was so strange that it, by itself, would have made 3I Atlas one of the most mysterious comets in history. The visual of that perfect expanding sphere of light was a powerful symbol of the object's weirdness. And the fragments didn't just appear in a perfect formation, they stayed in it. They maintained their uniform spacing as they moved outwards. Their motion was synchronized. They were moving as if they were guided by some unseen force or connected in some invisible way. This sustained, orderly dance was a deep physical puzzle. Gravity and the pressure of sunlight could not explain it. The random push of gas jets could not explain it. It was as if a new law of physics was at work, or as if the object was not a natural body at all. The persistent, disciplined movement of the fragments was a direct challenge to our models of how objects should move in space. It was, simply put, behaving in a way that seemed impossible. Then came the evidence of its composition. The spectroscopic data revealed that the material being thrown off by the comet was dominated by nickel and iron. This meant it had a metallic core. This is the profile of an asteroid, not a comet. Comets are supposed to be icy. Asteroids are rocky or metallic. 3I Atlas was blurring the lines between these two fundamental types of objects. It had the composition of an asteroid, but it was behaving like a comet with a bright flare and a giant coma. This contradiction was a major headache for scientists who try to classify objects in space. What do you call a metallic object that acts like an icy one? It didn't fit into any of our neat little boxes. To make the composition mystery even deeper, there was a noticeable lack of a key ingredient: water ice. While some water was detected, the amount was minimal. It was far too little to explain the huge coma or the violent flare. A normal comet's activity is powered by its water ice turning to gas. 3I Atlas was producing a massive comet-like display without the fuel that is supposed to power it. It was like seeing a giant bonfire with only a tiny pile of wood. It just didn't add up. The lack of water, combined with the abundance of metal, made it fundamentally different from any of the thousands of comets we have studied from our own solar system. So let's put it all together. You have an object from another star system. It has the metallic composition of an asteroid, but it has the giant coma and activity of a comet, despite having very little water ice. It flares up in a single, massive global event, and when it breaks apart, it does so in a perfectly orderly geometric formation of fragments that move in a synchronized dance. Not one of these features is normal. The fact that one single object displayed all of these anomalies together is what made 3I Atlas truly impossible. It didn't just bend the rules. It broke nearly every single rule that astronomers thought they understood about comets. It was a profound and deeply unsettling mystery. With the official science agencies remaining quiet, and with a collection of impossible facts on the table, the internet did what it does best. It became a global laboratory for ideas. The great debate began. How could all of these strange features be explained? The online forums, chat rooms, and social media platforms became a hotbed of theories. People from all walks of life, from professional physicists to curious high school students, all weighed in. The debate was intense, creative, and it covered every possibility, from the mundane to the truly extraordinary. Was this a new discovery of nature, or was it something else entirely? The first and most scientifically grounded set of theories proposed that we were seeing a new, unknown natural phenomenon. Perhaps our understanding of comets was too limited because we had only ever studied comets from our own solar system. Maybe interstellar comets are just different. Some scientists proposed that the orderly breakup could be explained by some kind of extreme geological activity on a metallic body. Imagine a planet-like object with a liquid metal core that somehow erupted, pushing the crust apart in a symmetrical way. It was a stretch, but it was an attempt to explain the impossible using known physics. Another set of natural theories focused on the interaction between the comet and the Sun. Could there be some previously unobserved process that happens when a metallic, interstellar object gets close to a star for the first time? Perhaps the Sun's intense radiation or magnetic field interacted with the comet's metallic body in a way that caused it to break apart in an ordered fashion. No one knew what this process would be, but it was a popular area of speculation. It was a way to explain the strangeness without having to rewrite the laws of physics. It simply required us to discover a new type of interaction. Some people tried to explain the uniform expansion by coming up with unusual forms of outgassing. What if the gas jets were not random? What if the fragments were all shaped in a very specific way, causing them to be pushed outwards at the same speed? Or what if the material was some kind of exotic ice that we've never seen before, which turns to gas in a very uniform and controlled way? These ideas were hard to make work with the laws of thermodynamics. The amount of energy required to push the fragments so perfectly seemed impossible to generate through simple outgassing, but people were trying to find any natural explanation they could, no matter how complex. The metallic composition led to another line of thinking. Perhaps we were wrong to call it a comet at all. Maybe it was a metal-rich asteroid that had somehow wandered into our solar system. But this just traded one mystery for another. If it was an asteroid, why was it behaving like a comet? Asteroids are not supposed to form giant comas and flare up. So this theory suggested that maybe there's a new class of object, a hybrid between an asteroid and a comet, that we had never seen before. 3I Atlas was our first example. This was a plausible idea, but it still didn't explain the most mysterious part, the orderly breakup. Then there were the more speculative theories. These were fueled by the strange geometric pattern of the breakup, the hints of unexplained acceleration in the leaked data, and the frustrating silence from the official agencies. These theories asked a bold question. What if the ordered breakup wasn't natural? What if the object or the force acting upon it was artificial? This idea was often dismissed by mainstream scientists, but it was a popular topic of discussion online. The pattern just looked too perfect, too disciplined, to be the result of a random, natural event. The idea that it might be a piece of alien technology, perhaps a probe that had broken apart to deploy smaller sensors, was an exciting and tempting explanation for many. The debate intensified. On one side, you had people who were convinced that there had to be a natural explanation, even if we hadn't found it yet. They argued that claiming something is alien is a last resort, and we hadn't exhausted all the natural possibilities. On the other side, you had people who felt that the evidence, especially the orderly breakup, was so strange that a natural explanation seemed more unlikely than an artificial one. Was 3I Atlas simply a natural anomaly, a one-in-a-trillion event that was pushing the boundaries of our scientific knowledge? Or was there something else entirely at play? Was this evidence of technology from a civilization beyond our own? The fact that no one could definitively explain it was what made 3I Atlas one of the greatest space mysteries of our time. There was no easy answer. Every theory had its own problems and unanswered questions. The object was a perfect mystery, one that challenged not only our scientific models but also our imagination. It forced us to confront the limits of our own knowledge and to consider possibilities that we had previously only read about in science fiction. The great debate was not just about a comet. It was about our place in the universe and the possibility that we are not alone. Regardless of what 3I Atlas ultimately turns out to be, the event itself has already changed the world. Its legacy will be about more than just a scientific mystery. The story of this comet marked the beginning of a new era of discovery. It was a moment that revealed the incredible power of the crowd. It showed us that the future of science may look very different from its past, and it all started with that one flare, seen by thousands of people at once. The event was a powerful demonstration of what can happen when you connect curious minds from all over the world. The story of 3I Atlas proved beyond any doubt that a distributed network of amateurs can, in certain circumstances, rival and even outpace professional observatories. The amateur community was the first to detect the flare. They were the first to confirm it globally. They were the first to capture hard evidence of the breakup, and they were the first to make all of their data publicly available. They were faster, more open, and in many ways more effective than the traditional institutions. This was not a criticism of the professionals. It was a celebration of a new and powerful partner in the process of discovery. The event showcased the power of real-time global crowd verification. In the past, a single observer who saw something strange might have doubted their own eyes. They would have had to wait for weeks or months for someone else to confirm their finding. But with 3I Atlas, confirmation happened in minutes. The network of connected observers acted as a giant global fact-checking machine. This ability to verify a discovery simultaneously across continents is a new and revolutionary tool. It makes the process of science more robust, more reliable, and much, much faster. This event demonstrated a new model for how science can be done. It was open from the very beginning. The data was public from the moment it was captured. The analysis was done collaboratively in the open, where everyone could see it. The debate and the theorizing happened on public forums, not in private meetings. This was science driven by public participation. It was messy, it was chaotic, but it was also incredibly dynamic and productive. It showed that you don't need a formal institution to do great science. You just need curious people, open data, and a way for them to talk to each other. The public's immediate access to the data fundamentally changed how the scientific story unfolded. The narrative was not controlled by a few experts or a press office. It was shaped, in real time, by the thousands of people who were actively involved in the discovery. This meant that the story was more transparent and more democratic. The public was not just a passive audience, they were co-authors of the story. This shift in control is one of the most lasting impacts of the 3i Atlas event. For perhaps the first time in a major discovery, the experts were often scrambling to keep up. The findings were coming so fast from the amateur communities that professional astronomers were often learning about new developments from Reddit threads and Discord chats, at the same time as everyone else. The traditional flow of information, from the expert to the public, was reversed. This was a humbling moment for some, but it was also an exciting one. It pointed to a future where the line between amateur and professional becomes increasingly blurred. Beyond the science, this event fostered an incredible sense of shared global experience. People who had never met, who lived in different countries and spoke different languages, felt like they were part of the same team. They worked together. They celebrated their successes together. They debated their theories together. This shared quest for knowledge created a powerful sense of belonging and community. In a world that is often fragmented, the mystery of 3i Atlas brought people together in a remarkable way. The excitement of this event has inspired a new generation of backyard astronomers. People who had only a casual interest in the sky went out and bought their first telescopes. They joined local astronomy clubs. They started learning how to take pictures of the stars. The event also highlighted the importance of accessible scientific tools and platforms. It showed the power of open-source software, affordable camera technology, and online communities. It proved that you don't need to be a professional scientist to make a real contribution to our understanding of the universe. The implications of all of this are clear. The future of discovery is not just in the hands of large institutions. It lies in the collective curiosity and capability of everyone. The story of 3i Atlas is a monument to what we can achieve when we work together. It is a reminder that some of the biggest questions can be tackled by a global team of citizen scientists. The power of the crowd is a new and powerful force in science, and its potential is only just beginning to be explored. And so, we are left with the questions. The mysteries of 3i Atlas remain. The story is not over. The comet is still out there, and the search for answers continues. The core mystery remains the most compelling. What caused the organized, uniform fragmentation of the comet? Was it a natural process we have never seen before, or something else? This question strikes at the heart of the entire event. Finding the answer will require more data and more creative thinking. It is the central puzzle that future observations will try to solve. And what about its strange identity? Why does its composition so strongly resemble an asteroid, yet it behaves like a comet? Is it a new class of object? Is it possible that many of the interstellar visitors that pass through our solar system are like this, and we've just never been able to study one up close before? Understanding the nature of 3i Atlas could reshape our understanding of how planetary systems are formed throughout the galaxy. It is a messenger from a distant star, and we are still trying to learn its language. Then there is the lingering mystery of the leaked acceleration data. Was it real? If it was, what does it imply? An unexplained acceleration, however small, suggests a force is acting on the comet that we cannot account for. If the data was fake, who made it, and why? This part of the story is a reminder that in the modern age of discovery, we must not only analyze the data from space, but also the information and misinformation that spreads here on Earth. The search for truth is more complex than ever before. The people's search for artificial radio signals found nothing, but the search is not over. The global amateur network that was created for this search is now a permanent resource. They continue to listen, not just to 3i Atlas, but to other mysterious objects in the sky. Their work is a testament to the public's desire to participate in one of the most profound quests in human history. the search for life beyond Earth, and they are doing it openly and transparently for all the world to see. The December reappearance of 3i Atlas promises to give us more data, and this time the world is even more prepared to watch. The global network of observers is larger, more skilled and better equipped. Whatever the comet does next, they will be there to capture it in unprecedented detail. The next chapter of this story will once again be written by the crowd. We're all waiting to see what it will reveal. This event has fundamentally changed how we view interstellar objects. For a long time, they were just theoretical concepts. Now we know they're real, and the first one we have been able to study up close has turned out to be more mysterious and wonderful than we could have ever imagined. It has opened up a universe of new possibilities. What other strange and impossible things might be out there, wandering in the dark between the stars? 3i Atlas stands as a monument to collective curiosity and global collaboration. It is a shared quest for answers, a mystery that belongs to all of humanity. It brought us together, made us look up, and inspired us to work as one team. The story of this impossible comet is not just about astronomy. It is about the power of human connection and our endless desire to understand the universe around us. And finally, it reminds us of a simple and beautiful truth. The universe still holds incredible secrets, and sometimes the biggest discoveries, the ones that change everything, come from the least expected places and from the most unexpected people. All you have to do is look up. What do you think happened to 3i Atlas? Share your theories in the comments, and don't forget to like and subscribe to join our journey into the unknown.